On a warm August night in 1977, a radio telescope in Ohio wrote 6 characters that still bother astronomers today. 6EQUJ5. On paper, it's just a spike in radio intensity, one column in a sea of 1s, 2s, and 3s. But when volunteer astronomer Jerry Emmon circled that sequence in red ink and scrawled a single word in the margin, "Wow," he accidentally titled one of the most enduring mysteries in the search for extraterrestrial intelligence. For 72 seconds from the direction of Sagittarius, the Big Ear radio telescope heard something that looked exactly like what SETI had been hoping for, a powerful narrowband signal right where theory said a distant civilization might choose to speak. It has never been heard again. A quiet giant in a cornfield. By the mid-1970s, Ohio State University's Big Ear radio telescope was already an oddity, a sprawling fixed metal structure near Delaware, Ohio, built not to make pretty pictures of galaxies, but to sweep the sky for radio whispers. It couldn't swivel like a dish. It simply stared at one strip of sky while Earth's rotation did the scanning. In 1973, Big Ear was reassigned to a risky project, a continuous search for artificial radio signals funded on a shoestring and run largely by enthusiasts. For 22 years, this was the longest-running SETI program on Earth. Night after night, an IBM 1130 computer would convert the telescope's data into columns of symbols on tractor feed paper. A 1 meant background noise. Higher numbers and letters meant stronger signals. The higher the character in the sequence 1 through 9, then A to Z, the higher the signal-to-noise ratio. Most of it was boring, terrestrial interference, hiss from the Milky Way, occasional spikes that never repeated. Volunteers would sort through the stacks by hand, looking for anything that broke the pattern. In mid-August 1977, something did, reconstructing 72 seconds. The shape of a signal, the wow signal, wasn't discovered in real time. Emmon saw it days later, at home, going through a pile of printouts. One column suddenly climbed from background levels up to a peak, U, corresponding to an intensity about 30 times stronger than the noise, and then slid back down again over the course of about 1 minute and 12 seconds. That shape matters, because Big Ear relied on Earth's rotation. Any continuous source in the sky, whether a distant galaxy or an interstellar transmitter, would naturally rise and fall through the beam over roughly 72 seconds. A passing artifact, like a nearby aircraft or a local transmitter, wouldn't necessarily match that clean profile. In other words, the signal behaved like something fixed on the celestial sphere far beyond Earth. Its frequency was another eyebrow raiser. After corrections, the signal appears to have arrived at about 1420.7 megahertz, uncomfortably close to the famous 21-centimeter hydrogen line at 1420.4 megahertz. That line marks the natural emission frequency of neutral hydrogen, the most abundant element in the universe, and SETI thinkers had long argued that any technological civilization might use that band as a kind of obvious hailing channel. So, a strong, narrowband signal, rising and falling exactly as a fixed celestial source should, right next to the hydrogen line. Then it was gone. The Big Ear's blind spot. Big Ear actually had 2 feed horns, 2 ears spaced slightly apart. As the sky drifted by, any steady source should have first swept through one horn, then the other about 3 minutes later. The wow signal only appeared in one. That missing second detection is often framed as a weakness, but it cuts both ways. If the transmitter were steady and continuous, then yes, you'd expect a second pass. But if the source itself flickered, turned on and off, or swept a narrow beam across space, then a single 72-second catch is exactly what you'd see. We do not know which scenario we're dealing with. We only know that in all the hours of data around that night, nothing similar appears. The sky patch. Because of the dual horn geometry, the team could only narrow down the origin of the signal to a thin strip in Sagittarius, with two candidate positions separated by about 0.5 degrees. There is no bright nearby star or obvious exotic object sitting exactly at those coordinates, although later analyses have combed the star field for promising candidates. In 2016, one researcher proposed that a sun-like star, about 1,800 light-years away, 2MASS 1928198226400123, not exactly a poetic name, might be a plausible home for an artificial transmitter in that region. That claim is intriguing, but low confidence. It rests mainly on the stars being broadly sun-like and in the right patch of sky, not on any follow-up technosignatures. If the WOW signal were a deliberate beacon, its message, if any, never made it to our tape recorders. Big Ear was a survey instrument, not a recorder of audio. What we have is the intensity pattern, not the underlying modulation. A cosmic knock at the door with no voice behind it. The hunt for a repeat? Astronomers did not shrug and move on. In the weeks, months, and decades after 1977, both the Big Ear team and others pointed antennas back to the WOW coordinates, hoping for a repeat performance. It never came. Big Ear revisited the region many times before the telescope was finally dismantled in the late 1990s, recording nothing with the same narrowband strength and profile. Later SETI programs with far more sensitive receivers, such as Project META and observations with the Allen Telescope Array, have also swept the area and the surrounding hydrogen line band. Still nothing. More recent work has chipped away at the details rather than the signal itself. New analysis of the original data suggest the signal's intrinsic power may have been even higher than first estimated, once you account for Big Ear's beam pattern and the source's likely position within it. Some authors have revisited the frequency, pinning it even closer to the hydrogen line. Others have explored whether some types of intermittent astrophysical sources, fast radio bursts, flaring stars, or even interstellar comets could mimic the event. But the central fact remains, in nearly half a century of searching, no one has seen another signal quite like WOW. What could it have been? This is where the deep archive lives, in the gap between we do not know and we can at least say what's likely. Let's walk the hypothesis ladder, from most mundane to most exotic, and tag the evidence strength as we go. Terrestrial interference. Radio telescopes are plagued by Earth-made noise. Radar, satellites, aircraft, even microwave ovens. If the WOW signal came from a transmitter on or near Earth, then its apparent celestial behavior would be an illusion. The Big Ear team took this seriously. They checked for known satellites and aircraft, for local transmitters, even for side-lobe pickup from strong off-axis sources. They found nothing obvious. The signal's clean rise and fall, limited to a single 10 kHz channel, and its proximity to the hydrogen line all favor a source at astronomical distance rather than a nearby broadband emitter. But nothing obvious is not the same as impossible. We do not have detailed logs of every piece of radio hardware operating in the world that night in 1977. A classified system, a malfunction, or a transient reflection from space debris remain logical possibilities, although there is no direct evidence supporting them. So terrestrial interference is a possible explanation, but one that lacks a specific, testable culprit. Natural astronomical source. Could some natural object in space produce a narrowband hydrogen line signal that just happened to mimic an artificial beacon? In the years since, astronomers have discovered a zoo of strange radio phenomena, from pulsars to fast radio bursts, FRBs. Most are either broadband, rapidly pulsed, or spread out over frequency in ways that do not match the WOW profile. The signal's narrow bandwidth and steady behavior over 72 seconds make most known natural mechanisms a poor fit. One high-profile proposal in 2016 argued that the signal might have come from hydrogen clouds around comets that happened to be in the field of view that night. The idea briefly gained traction because comets do emit near the hydrogen line, but follow-up studies pointed out several problems. The candidate comets' positions and brightness didn't match well, and later observations of those same comets with radio telescopes failed to reproduce comparable signals. The comet hypothesis is now widely considered unlikely. More recent work has searched for repeating behavior. If the source is some kind of rare, intermittent astrophysical object in that region of sky, then long-term monitoring should eventually catch it again. Sensitive facilities continue to watch. So far, silence. So the natural but unknown category remains open, but empty of a concrete candidate. Instrumental glitch or data artifact. Whenever a one-off event appears in old data, one explanation is brutally simple. Something went wrong with the instrument or the recording. Big Ear's design and the way the data were processed argue against a trivial glitch. The signal appears coherently in the expected format, follows the beam pattern in time, and occupies a single frequency channel rather than splattering across the band. That's not what you'd expect from, say, a noisy amplifier or a misbehaving digitizer. However, because the original raw voltages weren't recorded, only the processed intensity values, we can't rerun the data through modern pipelines. The hardware is gone, the exact operating conditions are lost, and our knowledge of the instrument's failure modes is incomplete. So an unknown instrument-specific quirk cannot be strictly ruled out, but it would need to be a very particular one. Technological extraterrestrial signal. Finally, the headline explanation. A transmission from an extraterrestrial civilization. Strong points in favor. Narrowband. Artificial transmitters are naturally narrowband. Nature tends toward broader spectra. The WOW signal appears confined to a single 10 kHz channel. Hydrogen line, 1420 MHz, is the canonical SETI frequency, chosen by us precisely because it's universal. That cuts both ways. We look there because we think it's logical. We find something there and call it suggestive. But the alignment is real. Beam pattern match. The intensity curve matches what you'd expect from a fixed point on the sky drifting through the telescope beam. Lack of obvious alternatives. After decades, no mundane explanation has gained broad consensus. Points against. No repetition. For a beacon designed to be seen, a single, unrepeated 72-second burst is an odd strategy. If this was a directed, long-term transmission, we should have heard it again, unless the beam was very tightly focused and Earth merely crossed it once. No modulation recovered. We have no way to show that the signal carried information rather than being a simple carrier tone or a purely natural spike. Anthropic bias. We are primed to see WOW as the best candidate we have which can inflate its perceived significance. In the language of the deep archive, the pattern of the signal aligns well with what an artificial beacon might look like, but the absence of corroboration keeps this firmly in the speculative tier. Even many SETI scientists describe WOW today as a lingering anomaly, neither solid evidence for aliens nor comfortably filed away as noise, a message in the margin. If you stand in the former field where Big Ear once sat, you won't see a dish or a tower now. The telescope was dismantled in 1998. The land turned over for development. The metal that caught the wow signal is gone. The IBM 1130 is silent. The people who built and operated that fragile experiment have retired or passed on. What remains is a single sheet of paper. On it, one thin column of characters climbs and falls in a way that refuses to be entirely ordinary. The numbers do not tell us who or what spoke. They do not even tell us that anyone did. They only tell us that on one night in 1977, the radio sky over Sagittarius was briefly, undeniably different. Every modern SETI search, every sprawling digital array scanning billions of channels around the hydrogen mine, rests in part on that unease. When we point newer, sharper ears at the sky, we are still, in some sense, trying to answer a handwritten question from Jerry Emmons' red pen. Not, was this aliens? But a quieter, more unsettling one. If this wasn't us, why did it only happen once?